Good day, Sir Atienza. I'm Joaquin Miguel B. Evangelista, and I am here today to discuss my project. So, the project that I'm going to discuss is all about what I have learned throughout the entire course. So, what we did in this course is to create lab reports and researches, and especially this one, the project. So, basically, we have 6 lab reports, then each containing a shop exercise. Then for the lab report 4, it has a research 1. Then for the lab report 5, it has a research 2. So we will start off with what I have learned from lab report 1. So for the lab report 1, I have my work here. It's entitled Collection of Hand Tools and Equipment Used for the Woodwork Shop. So what we did in this shop exercise is that we identify 40, which is 40, distinct hand tools used in the workshop. We illustrate the parts of the tool. We define the use of each tool. Then we define each tool on how it should be safely used. What I have learned from that shop exercise is that it is very essential to identify what tool is being used, what you should do and not do, and how you prolong that tool. I've also learned a lot because when I was a kid, I just used this kind of tool, then think of it as if it can do anything. But now I've learned that each tool has its own purpose. Next, we have the shop exercise 2. It is entitled the flat back. So what we did in this shop exercise is to gain the ability to manufacture a flat back, to understand the foundations of wood processing and the distribution of allowances when it comes to measurements, and finally, to understand the institution of the basic hand tools. To discuss the methods and analysis of this shop exercise 2, a one flat back pattern is easy and simple to make and mold. It generally has one broad surface that serves as the parting surface in the mold. It might contain 2 or no irregularities, may or may not have a core print, but extremely hardly it does have loose pieces. The soil tamper is exemplar of this easy type of pattern. A single piece or solid pattern is made without joints, partings, or any loose pieces. Such a pattern is usually flat back type, which may have few or no irregularities and no core print. The large horizontal cross-sectional or such pattern serves as the parting surface in the mold. The mold cavity of this pattern will be either entirely in the drag or entirely in the cope. So my conclusion for that shop exercise is that having the ability to manufacture a flat back will ensure basic knowledge on wood processing, since its basic patterns are visible to most of the wood processing. Measurements are precise with the method of allotting a clearance. During the wood processing, I was able to understand the institution of every hand tool. Just to add my recommendations, I only have one, and that is the part where the saw is being used. It is said that the correct operation of a saw is sawing, putting the blade slightly slanted forward. Next is the shop exercise 3, which I have here, is called link or linkage. The objective for this shop exercise is to operate a link with the right usage of supplied tools and materials, establish the concepts upon making conical core improvisations, sketch a methodological diagram for the analysis of its stock knowledge and power observation, and increase the mobility work of the worker or student in the field of woodworking tools appendages. To discuss the methods and analysis, a mechanical linkage is an assembly of bodies which connected to manage forces and movement. The movement of a body or link is studied using geometry, so the link is considered to be rigid. The connections between links are modeled as providing ideal movement are called joints. A linkage is composed of links and lower pairs. The simplest closed-loop linkage is a 4-bar linkage containing 3 moving links, 1 fixed link, and 4 pin joints. A linkage with 1 link is fixed is called a mechanism. So for my conclusion for this shop exercise 3 is that inhibiting the foundations of linkage and the ability to manufacture a link creates an essential knowledge. With the proper understanding of mechanisms, links are the center heart of kinematics of rigid bodies. Manufacturing is also important, conical core print. Together with the previous exercises, it will improve the mobility work of a worker and student when it comes to getting its dimensions. What I recommend for this shop exercise 3 is that this type of exercise must be in the form of a group. 2 to 3 members are recommended. Group work is essential for less responsibility and less time consuming, and also more coordination. Next is the shop exercise 4, which I have here again, is called the rocker arm. The objectives for this shop exercise 4 is to be able to manufacture a rocker arm design using wood as a material, to understand the principle of tapering, and also to know the proper design elements in the manufacture of a rocker arm design. To discuss my methods and analysis for the shop exercise 4, rocker arms are typically between the push rod and the intake and exhaust valves. They allow the push rods to push up on the rocker arms and therefore push down on the valves. However, in overhead cam applications, the cam will ride directly on the rocker arm. In addition to just changing the direction of the motion from up on the rocker arm to down on the valve, the rocker arm changes the amount of motion transferred. Typically, a rocker arm ratio of 1.45 to 1.8, meaning that for each 0.100 of push rod motion, you will exert 0.145 to 0.170 of valve motion. To give my conclusion, acquiring a knowledge on rocker arm manufacturing is essential in the mechanical engineering environment. The fact that I have passion for cars, it is very pleasing to recall the basic fundamentals, which is parts, ratios, geometry, and etc. of a rocker arm in an internal combustion engine. What I recommend for this shop exercise 4 is that I think this exercise should be performed as a group for less working time and faster progress. All the parts and procedure for manufacturing a rocker arm cannot be manufactured by an individual worker, as he or she will be exhausted immediately. For the tapering procedure, it should be performed accurately and precisely to maintain the 4mm offset. For the shop exercise 5, it is entitled Split Pattern Elbow Pipe. The objective for this shop exercise is to 1. To be able to produce an accurate replica of the piping elbow based on the measurements provided. 2. To ensure that the correct diameters for the piping are made. 3. To understand the concepts of friction fits and basic joining processes. And lastly, to enhance the skills developed for manufacturing processes. So for my conclusion for this shop exercise, that manufacturing an elbow pipe requires a lot of time and practice. Given the fact that there are various types of elbow pipe, each has its own dimensions that needed to be measured precisely and accurately. It is also beneficial to learn the fundamentals of an elbow pipe to better give additional knowledge on fluid mechanics or the behavior of such element inside an elbow pipe. The last shop exercise that I will discuss is called 3-piece pattern machine guide. The objectives for this shop exercise is to 1. To be able to accurately manufacture the machine guide to exact dimensions. 2. To understand the concepts of friction fits. And lastly, to be able to incorporate pattern or grid making to actual product develop techniques. To discuss the methods and analysis, casting pattern shapes casting mold, and the mold creates metal parts. So, the casting pattern is very crucial to the final parts. Therefore, the casting parts designer should consider more product details during the pattern design phase. Making a casting pattern is not only shaping a mold cavity, accurate dimensions, scientific feeding system, and mold removing method should be considered. There are two factors that should be considered upon creating casting patterns, namely materials of casting pattern, such as lower cost and less weight, resistance of water, durable and versatile. For the casting pattern allowances, such as draft allowances, shrinkage allowances, distortion allowance, and machining allowance. Casting and pattern differ from each other, whereas casting is a kind of process that manufacturers pour the molten metal into a mold where the material cools and solidifies. Pattern, in the other hand, is the primary shape of the mold, and finally, the product shapes according to the pattern. For my conclusion, manufacturing a three-piece pattern acknowledges more fundamentals in the workshop world. This workpiece may be challenging compared to the previous workpieces, but at least I learned how to manage precision and accuracy in manufacturing such workpiece. The workpiece can be manufactured either individually or by group as long as the correct dimensions and use of tools are met. What I recommend for the shop exercise is that, just like the previous workshops, it should be a group work. The final product contains three parts, so that is why at least three persons are working cooperatively, one part for each person. This serves also to double check the allowances and dimensions of the workpiece. So if I were to ask what my favorite shop exercise is, I would choose the shop exercise 4. And that is because, of course, it has something to do with automobiles. And as I said earlier, it's very pleasing to recall the parts of it. And, it really gives me that information to grasp. What shop exercise I don't really like is the first shop exercise. It's because it contains 40 pages, but to be honest, I just really did a 20 page, and yeah, I did it back to back just to, save papers, but hopefully I don't get a deduction from there. But yeah, to give what I have learned overall, it's all about being familiar from what you are doing, the tools that you are using, and the workpiece that you are working at. I've learned a lot, especially the things that I thought it was correct. Like, for example, when using a screwdriver, I thought it can also be used for flat or any shape of the screw, but as I learned, it gives me more information because, let's say, the screwdriver is only being used for that specific screw. Then for the workpiece, I've learned that it's not easy as I expected, as it needs, a lot of tools. Then using each tool is not also easy because, you need to exert the right amount of force to not break the tool and the workpiece. So if I were to give advice to the students that will take this course next term, I will advise them to, use your time wisely, use every amount of energy that you need because this is really, you know, exhausting to do. But at the end, you will, of course, learn something because in real life applications, especially in the field of mechanical engineering, you really need to do research before, applying something, doing a hands-on. This is to recall what you need to do, what precautions you need to take. So yeah, hopefully I've mentioned all the things that I've learned through this course. And for Sir Atienza, I would like to say thank you because you were one of those instructors that, deployed specific instructions on what to do on such exercises. And I hope you will still be my instructor next term. Thank you so much, sir, and have a good day. Stay safe.